Hello guys, in this video I'm going to show you guys how to do binomial distribution using the formula. In this example I'm going to be using this textbook. Let me zoom in a little bit. There we go. And I'm going to be using problem number 46 from section 3.4. So if you need help on this particular problem, this video will help you out. Okay, now using the formula. Here's the formula. Okay. All right. Now, one thing to keep in mind is that binomial probability distribution is used for experiment consists of a suite of n small experiments called trials, where n is the fixed advance of the experiment. 2. Each trial can result in one of the same two possible outcomes, either success or failure. 3. The trial is independent. And 4. The probability of success is constant from trial to trial, and it's denoted as p, lowercase p. So be careful. Lowercase p is the probability of success, as you can see here, here, and then here will be here and here. Capital P is the probability of what we're looking for, the actual probability of the binomial probability distribution. Okay, let me go ahead and start with number 1. And there I can also explain a little bit more about what these things mean. Now, before I forget, please like my video, comment below, share it, and subscribe. And please don't forget to check the description below the video and under the video for any timestamp that I might put in there to help you guys skip certain parts. Also, how to support me, and that's it. Yeah. And more about the video itself. Okay? Cool. Alright. So one thing to be aware about binomial distribution. Binomial distribution is similar to a normal distribution. If you guys know about normal distribution, what it is pretty much it shapes as a bell curve or a normal bell curve like this. However, the other thing different, this normal distribution, by the way. A binomial involves bins. Now, each bin, and it keeps going on and on and on. Okay, all right. Each bin is each of these numbers right here. It is where the x represents. X represents each number of bins. Okay, so for example, if I says 3 will be my bin, and the third bin, we want to know what is the probability at exactly at that third bin. Okay guys, let's go ahead and start. So we have, I will write this down here. As you can see, x equals 3, and your number of trials equals 8, and p, the probability of success, is equals 0.35. So this is saying that you have 8 trials. Of the 8 trials, you want to know the probability when 3 of them are happening of success. So the formula goes like this, as I mentioned down here before, like this. So let's write this down. We're gonna have n x, and we have p x, and then 1 minus p n minus x. Okay, and this is going to look like this. Sorry, try to keep it a little bit organized. Right. So for part A, it's going to look like this: capital P. And by the way, this is a lowercase p, by the way. Alright, lowercase p? Yeah, lowercase p. Alright, so here there's going to be capital P parentheses, capital X equal 3, that's a 3, equals the formula on the top, where n is going to be 8, x is 3, parentheses. This, by the way, this represents a combination, so we will be using the combination function in your calculator. Then we have P is 0.35, X is 3, and then 1 minus 0.35, and then 8 minus 3. Okay, now we're going to be using the calculator to help us to do this. First, we're going to do the combination here. We're going to do 8 math probability up here on the right side, and then option 3 right here because of the X, times parentheses 0.35 close parentheses raised to the third power, move to the right, then we have parentheses 1 minus 0.35 close parentheses raised to the power of 8 minus 3, and then we have that this equals 0.279. Okay, so that's the answer for this problem. Okay, now we're gonna go ahead and do part B. Part B is the same as part A. Our x, and this time our x is 5, our n is the same, and our lowercase p is 0.6. So we're gonna just plug into the formula. Again, there's your uppercase P, represent the probability. Here's gonna be 5. Here's where we're gonna do the this part of the formula, which is the combination 8, 5, or 8 given 5, 0.6 or 0.60. That'll be 5. 1 minus 0.60, 8 minus 5. There it goes. And then we're going to go into our calculator here. Now, I'm going to use this opportunity to show you guys something that you can use. You can use it in your calculator. You can go, since I already wrote down for the previous problem, I can go up here, so that this one, press enter, and it just change the numbers. To not get confused, I'll go all the way to the beginning here and work myself to the right. So the 8 stays the same, that's the n. X is 5 for this problem. P is 0.60 raised to the power of 5. Alright guys, so and here goes our answer. Alright, so it's right down here. Now if you guys want me to show you guys how to do this using Excel, feel free to comment below. Right now I'm just showing you how to use the formula and the calculator. That's pretty much it. Okay, so that's the answer right here. Alright guys, now let's go ahead and do part C. I already wrote down the numbers. As you guys can see, part C is asking for the probability between 3 and 5, when 3 is less than x, and when x is less than 5. Let me just go over here. In this case, because excuse me. In this case, because they want you to have between two numbers, or not two numbers. Well, yes, two numbers. We need to find the probability on each from 3 to 5. So I did the binomial distribution, as shown here in green, three times. When n equals 7, x equals 3, see, 3, 3. When n equals 7 again, add it. And when x equals 4, so I did it for when x equals 3, 4, and 5. It goes 4, the 4, and the 4, and the 5, the 5, and the 5. And I'm adding them up. Now in the calculator, we're going to do the following. We're going to go to second distribution, which is vars, and we're going to look for binomial PDF. Okay, press enter, and the trial is going to be your n, which is 7. Your p is your probability within those trials, which is 0.6. X value is 3. Enter. So we got 0.1935 plus, and now we're gonna do when n equals 4. Second distribution binomial PDF, and we're gonna change the the x to 4. Enter, and then we're gonna do the same thing with the 5. Got 0.2903 plus, and then second vars, right there, PDF 5. .2613 for significant figures should be enough at least. Don't do any less than 4. And now we're gonna add those up. Of course, using the calculator, we can just go select them and copy it. Let me start with the first one up here. Oops. All right, up here, the 0.19. Enter, plus 0.29. Enter, plus 0.26. Enter and enter again. So when you add them up, it gives us 0.745, and that's your answer for part C. C. Alright, cool. Alright, any questions? Just comment below, okay? Alright, let's go into part D now. A couple of things I wanted to emphasize or remind you guys is that we're doing binomial PDF. PDF stands for probability distribution function. Sometimes it's also called PMF, which stands for probability mass function. It means the same thing. Pretty much what it's all about is that we're dealing with a discrete random variable that's defined for every number of x. That means the probability at 3, probability at 4, at 5. Okay. Now in this problem here, they want the probability less than 1 when 1 is less than x. Okay. Now, just like the table, is gonna give you the probability at that point. Now, we want the probability when 1 is less than x. So just think about how would that look like, and how can you use the table or the calculator in this case to make this work, or the formula. So let me give you a little scenario here. Let me just do this. So when let me erase this part right here. Okay. So let me write things out. So when 1 less than x, n is 9, p is 0.1. So when 1 is less than x, probability when 1 is less than x. Alright, just think a little bit. So when we can find the probability when x is equal to 0. So pretty much what we're looking for, to be honest, is the probability all the numbers bigger than 1. So let's assume, and then put a different color here, there's 1, and you want the probability, that's a bad way to do it, and all these from here to here, all these other, so you want the probability of, so anything from 1 to a higher number, to infinity you can say. Alright, so what we do know is that we can find the probability of when it's when x equals 0, and then when we do 1 minus the probability when x is equal to 0, then we can find that becomes this side right here, the other side. So let's assume 0 is here, and we can do the probability that's 0, and if 1, and we do 1 minus is the other probability. Remember, probability is 100%, is the whole thing. So if the whole thing, let me rewrite this, cut up here. If the whole thing is 100%, and you want to know a 1 and bigger, that, or at least 1, at least 1. That means we can grab 0 and subtract by 100, and then we get the other probability. And why 100 and why 1 and not 100 is because we work with them. We don't do math with percentages. Okay? Sorry, seems like I'm talking too much now. Alright, let's get to the point here. My bad. Alright, to the point. Alright, so we're gonna do this, and how does this look like in the calculator? And of course, we're gonna plug in the numbers in this formula, but I guess we already did that way too many times. You guys should be, hopefully you guys get it by now. So you just go straight to the calculator. Turn it on, clear this, with second bars, and binomial PDF. There we go. Trial n is 9, p is 0.1, x is 0. Enter, and then we do 1 minus that, and there it goes. So that's your probability, your answer, 1 minus 0.3874, which equals 0.613. There it goes. Alright, well guys, I hope this helped you out. Please comment below so I know if I'm doing something right or do I need some improvements on myself, okay? Alright, see you guys next time. Bye.